So sometimes in our sciences, we have to solve a system where there's 3 letters that we don't know. And if that's the case, if there's an x, y, and a z, then we have to have 3 equations in order to solve that. If you were to do a graph of this, you'd have your x-axis, you'd have your y-axis, and coming out at us would be the z-axis. So it'd be in 3 dimensions. This would be the z-axis. And that's meant to come out at us, but I'm in 2 dimensions drawing, so I'm trying to illustrate that this is a right angle and this is a right angle to the face that's right here. What would happen is that these would be planes. They'd be like walls of a room. So this might be the first plane, and the next one might look something like, this. And they would intersect. This is tough to do. And the third plane might be over here. Whew, and say the planes all intersect right there. My picture is very poor. So what we need to do to solve this algebraically, so let's forget about this graphically because we need a computer system to do that. To solve this algebraically, what we have to do is we have to take these equations and eliminate either the letter x or, I'm pausing, please notice, the letter y or the letter z. If I were to get rid of the letter x's, I'd be trying to get, like if I added these 2 equations together, I'd try to get a -4 in front of this equation to eliminate x. Maybe if I used this one and this one, I'd go for a -8 in front of this one to get rid of the 8x. Bottom line, I have to use 2 equations at a time, either those two, or these 2, first and third. So first and second, second and third, or first and third is what I've got to do. I'm actually going to choose to get rid of the letter y because I've got a plus sign here and a minus sign there. So I could multiply equation 1 by the number 3. So when I do that, this 2 times 3 is 6x, and this y times 3 is 3y, and this minus z times 3 is a minus 3z, and don't forget to take the 4 times 3 and get a 12. So this was equation 1 multiplied by the number 3. I'm going to copy equation 2 down. So equation 2 was 4x minus 3y minus 2z equals a -2. Be careful in the copy process. I'm going to call these equations statements 4 and statement 5 because this is 1, 2, and 3. And then now I'm going to add equations or statements 4 and 5 together in order to get rid of the y's. So here 6 and 4 adds to be a 10x, a minus 3z and a minus 2z is a minus 5z, and 12 minus 2 is 10. And then I'm going to put a big old red box around this statement and put a star by it. Now I am going to title it statement number 6, but what I've done is I've taken the first 2 equations and gotten rid of the letter y. I have to do this again. I have to use 2 different equations. I use this one and this one. I think I'm going to use the first and the third now. So I'm going to come on over here and I'm going to multiply equation 1 by, let's see, I think the number 2. So that this will become a 2y, so that I can add it with this minus 2y. So if I multiply this equation by a 2, this 2 times 2 is 4x, 2 times y is 2y, and then a 2 times this minus z is a minus 2z, and finally on the right side of the equal sign, 4 times 2 is 8. I'm going to copy equation 3 down. It's supposed to be the word copy. So this one right here. So 8x minus 2y minus 3z equals the number 3. And these are now called statements 7 and statements 8 because way down here I had 4, 5, 6, so I'm working up here statements 7 and 8, and now I'm going to add 7 and 8 together to get rid of the y's. So 4 and 8 is 12x, the y's disappear. Here I have a minus 5z, and 8 and 3 is 11. And this is cool because now I have another equation. I call it my starred equation. that has an X and a Z in it, just like this one right here. So now I'm going to scroll a little bit, and what I'm going to do is I'm going to copy equation 6, which is 10x minus 5z equals 10, and equation let's call this 9, statement 9, equation 9. They're the two red equations. I'm going to put them side by side and have you see that now I've got to eliminate one of those letters. Well, it's going to be pretty easy for me to multiply this equation by just a -1 so that this will become a positive 5z. So if you don't mind, I'm just going to put a negative sign on the 12, a plus sign on the 5z, a negative sign on the 11, and now in order to solve for x, I'm going to add statements 6 and 9 together right here. So 10 minus 12 is a -2x. 10 and a -11 is a -1. I'm going to divide both sides by a -2, and finally I have an answer for one of my letters. X is 1/2. I will take this answer and put it into one of the two red equations. Please don't go back to the beginning. It's too much work. So one of the two red equations. So I'm going to take it and put it over here. So 10 times 1/2 will be 5 minus the 5z equals the 10. And then I'm going to subtract 5 from both sides to get the 5z alone, the minus 5z alone. On the right side, 10 minus 5 is 5. And when I divide by a -5, I find out that z is equal to a -1. Cool. So now I'm going to, so I don't lose these things, x is a half, z is a -1. Now I'm going to go back to one of these three equations with these two answers. Oh my, I think I'll go to the first equation because the coefficients are small and, you know, it doesn't matter. Either way, I'm putting a negative number in for z. So the first equation, I'm going to copy down here. So I'm going to go into equation, I'm going to put here 1, 2, or 3. I choose, Pat chooses to go into equation 1, which is 2x plus y minus z equals 4, and then I'm going to put in for x a half. This is nice because y is a positive. Then minus a -1 because it's minus whatever z is. So over here, 2 times a half is 1, and then here I'm going to add 1, the minus a negative. So on the left side of this statement, I have y plus 2 equals 4, and then I'm going to subtract 2 from both sides of this equation, and I finally get y is equal to 2, and then we often write this as an ordered triple in alphabetical order, the x value, the y value, and the z value. And the other reason I'm going to do this is I'm going to bring up my calculator and I'm going to take my original equations, which the first one is 2 times x, which is 0.5 or a half, plus y, which is 2, minus z, which is a -1. And the first equation said that should equal 4. The next equation said take 4 times x, which is 0.5 right here. And then it says subtract 3 times y, which is 2, and then subtract 2 times z, which is a -1. And look, you don't even need parentheses. And that equation said it should all equal a -2, so that checks. Then 8 times a half is the third equation, minus 2 times y, which is 2, minus 3 times z, which is a -1, and all that was supposed to be equal to 3, so 4, -2, and 3, again 4, -2, and 3, this is what I mean, way up here, these were equal to 4, -2, and 3, and I know that my solutions for this system are correct because I've checked them. We're going to do a couple more in our next video. I'm going to show a relatively simple one, and then we're going to solve a story problem as well.